The moons of the outer planets are nothing short of incredible. Their variety, potential, and scientific wonder are just mind-boggling. But few places are as bewildering and wonderful as the largest moon around Saturn, Titan. Titan was discovered on the 25th of March 1655. It was discovered by Christian Huygens, a famous Dutch astronomer. Titan orbits around 1.2 million kilometers from Saturn. It takes around about 15 days to complete one orbit around the planet. It's a decent way out. It's further out than the main belt of moons that you're seeing in this animation, and it's not really affected very much by the pull of Saturn's gravity, being over 1 million kilometers away. And not only that, Titan is tidally locked to Saturn, so it always presents the same face towards the planet, as is the case with most major moons in the solar system. It takes the same amount of time for Titan to rotate on its axis once. That's what tidal locking is. Titan is the largest moon in the Saturnian system by a very long way, and it's also the second largest moon in the solar system, only beaten by Ganymede. It's 5,150 kilometers across, which is nearly 3.5 times bigger than the next largest moon in the Saturnian system, Rhea. Its mass is about 134 billion trillion kilograms, so put that in perspective, that's about 2.3% the mass of Earth. Now, when you put this mass in perspective and calculate the density, it turns out that it's very low. It's 1.88 grams per centimeter cubed. So this low density is quite surprising. It means that Titan, even though it is bigger than Mercury, has less than half of its mass. And that means that it's likely made up of mostly water ices. So without knowing anything else about the moon, Titan feels like a fairly bog standard icy moon in the outer solar system. But of course, you can clearly see on these pictures in Space Engine that this moon is far from normal. And you can all of course see that Titan is the only moon in the whole solar system with a significant atmosphere. And in fact, it is so significant, it is thicker and more dense than Earth's atmosphere. The atmospheric pressure is about 45% more than on Earth. This atmosphere is made pretty much all from nitrogen. It's about 95% nitrogen and roughly 4% methane and other hydrocarbons. And when Pioneer 11 first visited the Saturnian system in 1979, it took some but very poor photographs of Titan and tried to peer through the clouds, but unfortunately Titan has a very thick haze layer that completely blocks out the surface. And even when Voyager 1 flew past Titan very closely in 1980, it was not able to peer through the clouds. And it was not until Cassini came along in 2004 and orbited Saturn for 13 years that we finally were able to characterize the surface of Titan. The atmosphere of Titan is already an absolutely incredible feature, but it gets even more incredible. On board the Cassini probe was a Titan lander. The European Space Agency attached the Huygens lander onto the Cassini probe, and on Christmas Day 2004 it was released from Cassini, and then on the 14th of January 2005 it finally landed on the surface, and we were able to see the surface from the ground for the first time. The first probe to ever land on an object in the outer solar system. What it saw was strangely familiar. It landed in what seemed like a dried up riverbed. There were stones that appeared to have been smoothed and eroded by a flowing liquid. You know how you get pebbles that have been smoothed by a river flowing on Earth. This is what Huygens found on Titan, but it didn't find any liquid on its landing site. Cassini stayed in orbit around Saturn, of course, and like I said, it flew past Titan over 100 times. We were finally able to see the surface of Titan for the very first time, and what Cassini saw blew our minds. We saw a landscape covered in sand dunes, but there were areas covered in floodplains and riverbeds. Clearly, fluid had flowed here in the past. As you can see from these images, you can clearly see that fluid has indeed been flowing on the surface, but no fluid was present when that image was taken. So where was the fluid? Had it dried up? The answer is no. On the north and south poles of Titan lies a whole variety of lakes. This was the first detection of standing liquid on another world besides the Earth. But we have a problem. The surface of Titan is minus 180 degrees Celsius, so it cannot be water, as it would be as hard as steel. In fact, there are mountains on Titan that are made from water ice. So what is the liquid that we see at Titan's poles? This is when you have to look at the atmospheric composition. 98% of the atmosphere is nitrogen, but the boiling point of nitrogen is minus 196 degrees Celsius. That's too cold. Titan is minus 180 and it's not cold enough to liquefy nitrogen. But there is a small amount of methane in the atmosphere, 2% of methane. And it turns out that these lakes that we see on the surface of Titan are in fact lakes of liquid methane. Flammable gas is a standing liquid on the surface of a moon over 1 billion kilometers from the sun. So you might be wondering, how does the liquid methane get from the poles to the equator, which was where we were finding the canyons? There are no lakes of liquid methane anywhere besides the poles. Now, it turns out from data from Cassini that Titan has a similar weather cycle to Earth. There are seasonal floods of methane that occur on the surface of Titan. The sun, the very weak power and heat of the sun, evaporates the liquid methane from the lakes and turns it into clouds, just like we see with water on Earth. And the clouds then, over the course of the Saturnian year, which is 29 Earth years, slowly but surely move down and down in latitude across the surface of Titan until they reach the South Pole, and then they go all the way back up again as the seasons change. And in the process, just like rain clouds on Earth, they unleash their rain torrents. Yes, it rains methane on the surface of Titan, and we have seen floods occur on the surface of Titan. It is just a world of complete and utter fantasy. No one would ever have thought that we would find such a world in the outer reaches of the solar system. And this is because Titan is just at the right temperature and pressure for methane to exist in all three of its states: solid, gas, and most importantly, liquid. Just like Earth has a hydrological cycle, a cycle of water, Titan has a methanological cycle, a cycle of methane. Now, this is incredibly exciting. It means that this is likely quite a common feature of the universe, that we can find these worlds where pressure and temperature is just right for these liquids to exist in the forms that they do. So Titan, even though it may not be liquid water we're seeing, is laying the foundations for our search for life elsewhere in the universe. Because if worlds like Titan exist, that is probably the most similar world to the Earth in the whole solar system, then there are surely many, many worlds out there in the universe that are just like Earth too. The excitement with Titan does not end there. On the surface of Titan, we have observed what we think are cryovolcanoes. And that's very interesting, because it may mean that there is an ocean of water beneath the surface. But that is just very heavily informed speculation at the moment. There is no way we'll ever know if there's an ocean beneath Titan for many, many years to come. We definitely need to learn a lot more about Titan. There are very, very few scientists across the world that actually think there is life on the surface of Titan today. But the excitement still does not end with this incredible moon, because its lakes are not just made of methane. They're made of all sorts of hydrocarbons. Methane is the dominant molecule in those lakes, but there are traces of ethane and propane and even butane. So there's a clear hydrocarbon system on Titan. It's clearly very, very abundant in hydrocarbons. Now, why is that important? Because life on Earth is pretty much all made out of hydrocarbons. Hydrocarbons are the makeup of life on Earth. So in billions and billions of years in the future, when the sun is dying, it will get a lot bigger than it is today, and therefore Titan may get a lot more solar energy, and so the world may heat up even to maybe as warm as Earth is today. The ice mountains that were hard as steel before will melt, and they will form into oceans. The methane lakes will evaporate into the atmosphere, and the natural hydrocarbons of Titan may form life. Just for a brief few million years before the sun eventually loses its outer layers, Titan may have its moment in the sun and have some life. While we may not ever see the exciting distant future of Titan, what is exciting about the near future is that NASA is planning a mission to explore this incredible place. This is one of my favorite and most exciting missions that is coming up. It is called Dragonfly, and this is a rotorcraft that's going to fly around the atmosphere of Titan and fly to different sites on the surface to investigate what Titan is actually made of, to see what the surface looks like, and of course investigate Titan's potential as an origin for life, among many, many other science experiments that we're going to conduct on the surface. Maybe it'll encounter a methane rain shower or two, who knows, but it is very exciting. Dragonfly is launching in July 2028 as of recording this video, so still 2.5 years until launch just yet, but when this mission does launch, it's going to be very exciting. And even with the potential cuts to NASA science, the US government is still funding Dragonfly. It sees the potential in this mission, and I cannot wait for this thing to launch. It will launch in 2028, and it should arrive at Titan by 2036. And so therefore we can finally answer some more questions about this most bewildering and wonderful moon. Thank you everyone so much for watching this video. I absolutely love Titan. This is probably my favorite moon in the whole solar system, and I cannot wait for Dragonfly. It's going to be so exciting. I hope you all enjoyed. If you did enjoy, please leave a like down below and consider subscribing. It will mean a lot to me. Thank you very much. Be sure to vote on my YouTube poll in my community to vote on what you would like to see as a video next. Thank you all so much for watching once again, and I will see you all in the next video. Goodbye everyone!